Look, if x is less than or equal to minus 1, what this means is that I multiply both sides by minus 1, I will get that minus x is bigger than or equal to 1. Somebody will ask me, why do you have to multiply by minus 1? Because I have minus x somewhere here. So I need to have minus x appearing here. So if what I do to this guy, I must do it him. So I multiply both sides by minus 1, I get minus x is bigger than or equal to 1. Now, I want to see 1 minus x. So I need to add 1 to all the sides of this inequality. So I have this things, 1 minus x is bigger than or equal to 1 plus 1, which is 2. And so 1 minus x is bigger than or equal to 2. Therefore, for anybody, any x that is less than or equal to minus 1, 1 minus x must be bigger than or equal to 2. And so I have this interval as the range. In this interval, this is the range of f. Okay. When x lies in this interval, my function is constant. So f of x is equal to 2 for each x in the interval negative 1, 1. So the range here is just a singleton 2. So I take singleton 2. What about here? If x is bigger than or equal to 1, so x bigger than or equal to 1, I know that x squared will be bigger than or equal to 1 squared, which is 1. And this further says that x squared plus 1 will be bigger than or equal to 1 plus 1, which is 2. And so x squared plus 1 is bigger than or equal to 2. Again, I have the interval 2, plus infinity. So within this interval, the range of our function is this. So when we take the union of this, and that, we get that the range of f is precisely the interval 2, plus infinity, union a singleton 2, union again 2, plus infinity. And this will still give us the interval 2, plus infinity. So that is the range of our function. This video is precisely an assignment I want you to try your hands on. As you solve the problems, try to feed me back on whatever solution you get. If you're having some challenges, also let me know in the comment section. But whatever solution you're able to do, if you feel comfortable with it, no problem. But if you're in doubt, you can let me know on the comment section. This is what I have, is it correct? Then I will respond to you. So I take this as exercise. One. Let's define f of x to be 1 over x minus 2 multiplied by x minus 3. The question is, find the domain of f and the range of f. Number 2, I define f of x, or let me call it g of x, to be the absolute value of x, where the absolute value function is what we already know. Then the question is, find the domain of g and then the range of g. Let us consider the greatest integer function we have learned. It is the function we denote by this, defined on R into z. The greatest integer function. As we know, what this function does is that for any real number you give to him, you look at that real number and consider all integers less than or equal to the number you have given him. If, after considering all those integers less than or equal to the number you gave, you will look at the greatest of all of them. That greatest of all of them is the output for the given real number you have. That is, if I consider this is equal to the greatest integer that is less than or it is equal to the value x. For instance, if I want to take a look at the greatest integer less than or equal to minus 2.5, what this function will do is it will look at all integers that are less than or equal to 2.5 and give me the greatest. Notice here that minus 3 is less than or equal to, is strictly less than negative 2.5. Minus 4 is an integer less than 2.5. Minus 5 is an integer less than minus 2.5, and so on and so forth. It will examine all these integers that are less than minus 2.5 and then give me the greatest. The greatest from what I've explained is nothing but minus 3. Therefore, the greatest integer less than or equal to minus 2.5 is minus 3. This is what this function does, just to remind us of what we know.